All right, good morning. I'm Ben. I teach at the Laboratory School of Finance and Technology in the South Bronx. I will put up my name, I think, at the end of this thing. So today I'm going to be talking about how I approach small group instruction and differentiation in my classroom. I'm going to try to show you actual concrete examples of what that looks like rather than just using education buzzwords. How many people in here are a teacher? Just show of hands. Of any, if you consider yourself a teacher. If you can keep your hand up if you are in K-12. Okay, cool. Thank you. And how many of you teach CS? Awesome. My hope is that if you don't teach CS, if you do teach CS, these practices will be helpful. My background was not in computer science. I am a member of the software engineering pilot, which a couple people here are or were as well. So we're, I believe, 19 schools now in the DOE that teach software engineering as a class, somewhere between 6th, as of this year, 11th grade. Next year will be complete, 6 to 12, and piloting K to 5. So we are in schools in every borough. We're in schools that are unscreened. We're in schools that serve English language learners, special ed students. So we serve everybody somewhere in our pilot. My school is 98% free and reduced lunch, 99% students of color. The CS classes at my school are 51% girls. So my school, in some ways, is very typical of a New York City middle high school. In some ways, especially that last one, is not typical. So I'm happy to talk about that stuff as well. This is mostly focused within the classroom, not at the school level. So the reason I'm calling it juggling with one hand is everything that I'm going to talk about, and I hope that it's good, is stuff that I do by myself, meaning I don't have a co-teacher. So if you are a teacher in DOE and you're used to teaching ICT classes or classes with a co-teacher, I teach those same classes, but without a co-teacher. So I'm trying to bring as much of the differentiation and meaningful, rigorous experiences for different learners that I can, being just one person in the room. All right, so the framework that I'm going to start out with is that in any given classroom, any classroom, yours, mine, there is going to be a distribution of students that's represented by this. And I find this very helpful because usually when you talk about differentiation, you hear words like high, medium, low. Sometimes people say they're slow or they're fast, or even like levels. Our colleagues in ELA have very precise ways of talking about levels, right? We don't have that for CS. Maybe we will in 10 years. We don't have it now. And I actually think it's helpful the way that I plan my lessons. I don't think about that. I think about this, and I think about it, the reason I made this GIF is I don't think about it as a static distribution. It's not a bell curve. It's not going to be a linear progression. It is not anything that's easily mappable. It's just helpful to have these three things in mind. This group could be one kid. It could be 25 kids. But those three groups are always going to exist. So when I'm planning experiences in my classroom, I try to plan at least these three things. What can I come in and do as a student who's totally lost from the day before that will help me catch up? What can I do for the middle group, that's where I'm planning my lesson to be, and how do I always make sure there's a rigorous experience for those students that are always going to outpace me? I think that CS gives us the opportunity, because we're going to have probably one device for every student, there's no excuse for not having next work. One of my biggest pet peeves is the idea that the computer should be, a different task should happen when you finish early, right? So kids think they finish their work in a class with computers and they can do whatever they want with the computer. The computer's a tool. When kids finish their work in math or in English or in social studies, we don't say break the pencil in half and throw it in the air. We say do an extension, do something more interesting, make it better, go back and edit. Here's another challenge for you. And that's the kind of model that I want to have for CS as well. So if you think about a classroom of 30 kids, my school has 42-ish minute periods. People who aren't educators, and bless them, they tell us things like, you should find the passion of every individual kid. And I think that's beautiful, and I realize I'm being recorded right now. I don't have the time for that. If I found the individual passion of every single learner in my average class, I'd have 84 seconds to talk to that kid about their passion. By the time we finished making that not awkward, we'd be done, right? So if you really want to talk about individualized instruction, I think there's a lot of promise there from technology. I'm not there yet, and I'm not going to promise you that we can get there in the next hour. What I'm talking about is groupings. So I'm not talking about addressing each individual kid with a computer, although that's obviously possible. I'm talking about thinking specifically in groups. And the way that I do those groups, I'll show you some examples in a bit. But the first premise I had when I was, and these are things that I tried in my classroom, was that you could either be engaged or you could be taking notes. So right now, a lot of you are staring at a computer. That's a hard way to pay attention. It's a really hard way to pay attention. So one of the things I do in my classroom, 9 times out of 10, when students walk in, they're not going straight to a computer. I think this is really important for setting a tone. And that's pretty much the only whole class instruction I do, is not at the computer. You will almost never see me doing this. Everyone with a device, me with a device. So when students walk in, they go to a table. And the way my room is laid out, I can show you in a bit, but my classroom is not a horseshoe. So the computers are away from the edge of the room, but there's work tables in the middle students can be at that don't have any devices. They have some kind of unplugged, low stakes, we call it a do now, you might call it a launch, or depending what school you're at. Something they can do without anything else. Sometimes that's recalling a definition. So we're in the middle of an Arduino unit right now, and I want them to remember the difference between a digital write and an analog write. So I might ask them, what will this do, what will that do? But it should be something they can experience without their computer device in front of them. I started with this premise that you could either be engaged or you could take notes. And then I started thinking about these groups. And so instead of doing a whole class mini lesson, what I started planning was about 15-ish mini lessons a week. Why 15? I had those 3 groups, totally lost, totally with me, totally bored, and I had 5 days. And I thought about students progressing through those experiences. So you might not hit every single one of those experiences in a week, but my goal was to say if you were totally lost on Monday, maybe by Wednesday you're totally with it. And you could actually be in that way ahead group by Friday. And the way that I did that was I would pull students in for mini lessons that were different. So I might sit with 20 kids and 5 and 5 for completely different lessons. And I started out saying you can't take notes. I don't want you to have paper in front of you. I want you to be totally engaged with what's up here. And the conversations we were having because of the groups those students were in were meaningful, and they were great, and they were solving challenges. And all I was doing was typing. They were telling me how to solve. I would put up something on the board. They'd debug it. Or we'd say, how can we build a Python program that calculates your GPA? And they'd talk me through it. All I did was type. And I'd say, OK, go build it. And they go back to their seat. Phew, it's gone. And so I started to think, well, OK, so I've gotten them engaged. I've gotten them solving problems. All I am doing is typing faster than them. Their hitting experiences matter, but then they're going back to their seat. And something between the work table and the computer table, they're losing it. And you may have seen this in your classroom where students can explain it to you, or they can do it when you're with them, and they walk back to their computer, and they can't do it. And I thought, teaching CS, I was going to be safe from what most of our colleagues experience, which seems to be like a never-ending cavalcade of Post-it notes and chart paper. And it turns out, at least for my kids, Post-it notes and chart paper were going to come back around. So what I did was I would notice there were kids who brought their notebooks to the group anyway. They were often my most diligent students. They're like, I'm going to take notes even if he tells me not to, because I want to have them. And they would try to copy down every single thing I wrote on the board. Anybody teach CS and see this? Kids trying to copy code by hand? It's painful. They will never, ever copy code as fast as you can type it, right? It doesn't make sense. And so what I started to do was a little bit evil. I said, OK, you can take notes now. Let's all take notes. But I'm going to give you a single Post-it. And that's the only piece of paper you can bring with you. You can't even bring paper. I'm going to give you the Post-it. You sit here. This is your notes for today. And again, they first started trying to cram everything I was writing now onto the Post-it instead of into the notebook. And what happened, and I'll show you how I didn't, but what I tried to move them from doing was copying code to copying my comments. The reason being, the comments, and I'm trying to show them this practice, should be, and we can have this debate later, but for learning programmers, should be a narrative of your thought process. Here's what I tried, here's what didn't work. Here's what I tried, here's what didn't work. Here's what he told me would work, it didn't work, he's wrong, here's why, which happens a lot. So there are programmers who have told me at events, your code should be so clear that it doesn't need comments. I wrote a very angry blog post about why I think that's stupid. I'm happy to talk about that too. But if you're 12 years old, I need you to write comments because I need to know your thought process. The same way that the expectations for a math class have shifted in the last 5 to 10 years. You should be able to explain your process. You should be able to explain your process in CS as well. And the easiest way to do that is through comments. So it was easy to say, oh, write down the hashtags, or write down the // or write down the whatever language we're in, right? But if you think about how most coders like to set up their environments, and this is like very pedantic but important. If you look at most IDEs, you look at most people's text editor, if you're teach CS, you open your text editor right now, 9 out of 10 of you will have what color background, probably? Dark or light? Dark, right? You're going to have dark text, dark background, light text. You're going to have some nice, pretty, maybe it's like, I don't know, Twilight, maybe it's the Solarized, but it's going to be a dark background. And what are your comments going to be more or less prominent than the code? Less, deliberately less so, right? If you look at, and I've done some really dorky color analysis, if you look at pretty much every syntax highlighting theme, you can just download the top ones for Sublime or whatever. Comments are hard to see. So what they do is they do this. The top one is what most programmers like. And if you're a kid and you're in a classroom that has Southern exposure, like mine, and you're trying to read the comments, it's impossible. And so what I did was I made a new syntax theme, and you can definitely see my comments. And what I started to do was I made them pink because I had a stack of pink Post-its. And so it visually cued the kids, okay, I have this pink little thing in front of me. I'm going to write down the pink stuff on the board. Eventually, they got in the habit of knowing my comments were pink, even if the Post-its were green or whatever. They figured it out. They're pretty smart. But what this did is it said the thought process is actually more important than the code that I'm typing. And you are doing the thought process. I want you to think about the thinking. You can go back to your computer and type this function or this print statement or whatever the heck it is. But the comments are what you guys were talking about. The comments are what you were doing so productively at the front with your group and losing as you walked back to your computer. And what I noticed, and I took pictures of them because there's a great Post-it app for the iPhone if you have it, I tracked their Post-it notes. So I collect them at the end of class. I didn't leave with them. And I made you a little graph of what happened using just these two interventions, totally to scale. But this, I can't show you the production code of my students, partially because it's all on my computers at school and partially because it has their names on it, but you can take my word for it. The amount of code that they produced in a single period, it did double. And I know it doubled because I planned lessons and I used various tools I'll talk about in a second that had predictable endpoints, and they were going through it twice as fast. So they were producing, if they were in CodeStars, or they were in Codecademy, they were doing a project for me, they were producing twice as much code. And so I had to change my pacing, which is awesome. But if you think about that first thing that I showed you, what it does to this is it lets you shift through these groups much faster. And I don't want to have every kid end up in totally bored, but I want to have as much independent working as possible. And so by not thinking about teaching each individual kid and by not thinking about teaching the whole class, I'm trying to push kids through these experiences. And the thing that's nice about that last group is they don't need to hit every experience. That's fine. So if they don't need a lesson, if they've figured out how functions work and they don't need me to debug it with them, they don't need to come sit with me for that. And I let students be very, very honest about, you know what, I don't need that. Or actually, you put me in the high group, the totally bored group, and I'm totally freaking lost. I just happened to get lucky yesterday. And they self-report, and they're very honest. So that was a lot of me talking about what it looks like. I'm going to show you now what it looks like. This slideshow will be shared. I made a separate slideshow of a whole bunch of lessons, like a whole bunch of lessons that I'm going to take you through quickly. How am I doing so far? Thumbs up, helpful, thumbs middle, thumbs down. OK, cool. So this is going to be, it starts with JavaScript. It's almost entirely Python. I just was pulling slides I thought worked well. And of course, slides that work well are different than lessons that work well. But these were, I thought, representative of experiences that were worthwhile. So for example, this is my absolute favorite thing to do with a small group when they're learning conditionals. So if you want to just take a second, you'll all probably get it. Why am I being mean? Yes. No, it's not. Why am I being mean?
Because you switch the logs, you switch the console logs.
Right. So what are they both going to print?
There you're wrong.
Right. Even if you're right, it's going to tell you you're wrong. So one of the things that's interesting about talking to 12-year-old programmers is they say things like, it doesn't want to, right? All the time about code. It doesn't want to work. It doesn't want anything. But that's a really hard vocabulary pattern to break. It doesn't want to work. It's a computer. It doesn't want anything. That's fine. But I love putting them in this position where they know they're right, the computer's telling them they're wrong, and then they realize that strings are meaningless, essentially, right? That you could write, I'm a giant purple elephant. It's going to print that if you tell it to print that. And so you can just sort of see these light bulbs explode in their brain when they realize they can make the computer say ridiculous things. And then what matters is certain parts of the logic. The logic of English doesn't really apply anymore, but there are predictable patterns here. And I can make it say goofy things, but more importantly, I can make it say things. And I understand why it's saying them. It's not saying I am right because my math is right. It's going to say I am wrong because my math is right. And that's a really powerful disconnect to have. To be able to say to hold contradictions in your head, like I'm not a developmental psychologist, but that's a tricky thing to do. It's tricky for adults to do. And so this is a really great just sort of discussion starter. And I will put up that and have students scream at each other for about 2 minutes. And one of the valuable things about how I do these groups is there'll be a group, so maybe you guys are my totally lost group, and you'll be looking at this and screaming at each other. The rest of the class is working on something else, and I'll show you the something else in a few minutes. But then while they're screaming at each other, I can walk around. And I set a timer on my watch, and I walk around for 2 minutes, and I come back to these guys, and either they've reached consensus or they're still screaming at each other, and then we can talk about it. But there's an experience happening with urgency for everybody. They're not waiting for me because they have something very clearly to do. They're not waiting for me because they have something very clearly to do. So here's an example of sort of what that looks like. So one of the things I use to introduce syntax in JavaScript and Python especially, and this is in 8th grade mostly, is Codecademy. Has anyone ever used that? It's an online learning platform. It has Google Apps authentication. There are other online learning platforms with Google Apps authentication in the audience. I like them too. Hi. For my purposes, the platform that you use and how accurately it tracks is actually less important than the appearance that it's accurately tracking students. If they feel like I'm in this group for a reason, and you're like, maybe you are, maybe you aren't, but you're in a group and you're doing something for a reason, and I have you engaged and pushing through and you're practicing syntax, that's a worthwhile use of your time. If you should have been in group 2 and you're actually in group 1, okay, but you're actually working and you have a clear sense of I'm in the middle of this distribution, I want to move to the next thing. And this also creates urgency for students, and they very clearly want to move from one to the other. And you see kids, the best thing is they're not asking me for help. So if you're one of the 12 anonymized kids in group 2 and I'm working with group 1, who are you going to talk to for help? You can't talk to me. I will not speak to you. Who are you going to talk to? Group 3. You're going to bother group 3. And the way that my room is set up is that every screen, you can see at least 5 screens. And so they're seated I can't say this word, heterogeneously. Is that right? So you can always see someone who's doing a different experience than them. So it's not hidden. It's not like you're sitting in the corner because you're in group 1. And when you finish group 2, you just go to group 3. And this is all linked on my site, so they know as soon as I'm done with this track and Codecademy, I go to some project on Mr. SK, that's me, his site. And so they can move fluidly from group to group. And I'm tracking that on the back end, basically through Google Forms. It's super simple. So I know where they are at all times, but they also have the sense that they don't need to wait for me to get to that totally bored group. And the totally bored group, of course, is where you want everyone, where they're like, I'm done with this closed-end learning platform. I want to go build my own thing. Part of the problem that happens in those first 2 groups is the difference between a linter and a test suite. So Codecademy, Codesters have great linters. They also have test suites. So for example, if you're a kid and you mess around with something in a code on a learning platform, it will tell you you're wrong. You're not wrong. You're wrong for what the company wanted you to build. You're not building to spec, but your code isn't wrong. And that's a really tricky conversation to have with 12-year-olds. And so part of what I've done to ease that conversation is to not have it. So the reason the 3rd group is not just lessons 13 to 19 or whatever the heck it is in Codecademy, the reason it's like tip calculator and beyond, is that I want to push you out of the closed end. So you can easily drown yourself in an IDE, but I think even in 8th grade, that's preferable than thinking that Codecademy or Codesters is the IDE, right? I want you to see this as a worksheet, and they're the greatest worksheets in the world. I taught social studies in a past life, and the best worksheet I could make was still a piece of paper. And once I made it, it was done. And if they completed both sides, it was done. I couldn't add a 3rd side to that worksheet. I couldn't add a link to a next thing. Even if it was an online worksheet, I could only add so many links. They weren't going to go write their own source, right? So when they're done annotating the high-level source and writing the essay and writing a counterclaim and having a partner peer edit it, there is a finite point at which they're done. And one of the things that's nice about teaching computer science is you can just keep pushing that. And so I think of sort of those first 2 groups as Codesters, Codecademy, Khan Academy, other things. They're all the greatest worksheets in the world because they give you instant feedback and there's more exercises and they're really fast and some of them even look nice. But they're worksheets. They're not building your own thing. So I try to push my students out of that. And the best part about this is, so if you can count 7, 12, and 7, that's nice, right? That's the distribution. Totally normal. Any math teachers? No? Okay. It's a normal distribution, right? All right. So this is the next day. So not normal, right? I didn't do anything. They have shifted themselves. Uh-oh, what happened? Looks like everybody went down, right? What actually happened was I now have 21 kids that are ready for a project that's not in an online learning platform. They have moved out. They are now in an IDE. This one happened to be a web-based IDE. It's called Trinket. It's great. They've later moved this project into PyCharm, which is a professional IDE. They are moving through and out, right? So they are doing something that is structured. It's a structured learning experience. There's a finite end. There's a linter. There's a debugger. There's a little character. What's the yellow guy that pops up in Coasters? There's a little sprite that comes up and tells you you're right or wrong. They get feedback. And then suddenly they're in the deep end. But they're able to do it. And again, 5 kids are still struggling somewhere with the syntax. So I always going to have those 3 groups in my brain. But 21 of these students are in 8th grade and they're working in IDE. And that's pretty cool, I think. So This is the sort of thing they will see for that project. So you saw 21 of them were doing this project. This project was a GPA calculator. Our online grading system, for reasons I don't understand, doesn't calculate your GPA. So there's a need in the market. They're going to solve it. We talk about some general pattern. And if you know Python, you might dispute my syntax here. I don't really care. It's fine. So we start by asking some questions. How do we ask questions? Well, in JavaScript, they had prompt. And in Python, they're going to have input. Maybe they'll have raw input, depending on how we feel that day. Or if we're using Python 2 or 3, which is also confusing, that's fine. So general pattern, though, they're going to see again and again. Ask a question, store in a variable. Ask a question, store in a variable. That is the sort of insight that's on one of those Post-it notes. It doesn't say math equals some string input, whatever. It's going to say ask a question, store it as a variable. And might even have a reminder. We need a variable for each class. And we actually are going to need one more variable because we're going to use that last variable to add up all the ones we had before. So again, you see, these aren't pink, these are blue, because this is earlier in the year. But you can see what they're supposed to be copying down are the comments. And I've deliberately made them as prominent or more than the code. This might be the most useful thing that I've actually done for my students. The other one is, this is a pet peeve of mine, but if you try to project Codecademy, Codesters, lots of things on a board in daylight, you can't read it because it's a dark background and you can't. So these are all Google slides, but these are the sorts of things that my students will see at the board. So this was that first group that you saw, the 21 kids. 21 students see these slides, take notes. I don't talk to them for 30 minutes. They go build this. And I really won't speak to them. Like, they will ask me a question, and I will say, I'm not going to talk to you because I'm going to go help these 5. So we go through, and then it goes off the board because I'm with the next group. So now this group was the next day we were debugging. So we have some problems here. So this is actually a student's code. So they had a couple issues. They had a typo. They meant to type SE. They typed SG. And then their addition at the bottom, they actually called the variable something completely different. Their cases for ELA were different. So they had lowercase l and a capital L, little things. But again, using color, using things that students are going to recognize to highlight their mistakes. This is not a linter. This is not a test suite. This is yellow boxes in Google Slides. This is not like, I don't code anything to do this. I'm just dragging boxes and filling them with color. So then we put an insight. Again, here's something prominent. Post-it notes that day. Guess what color they were? Yellow, right? So keep going. Good. Okay, there's a lot of these. Then, I don't know what this slide is. Oh, here you go. So this will be like a do now for one of those groups, right? So I pull you a group, and I don't know what the problem was here. Oh, yeah, right? So what the hell does this mean? So Sean, I think it was Sean, gave a talk about how do we teach kids how to read in CS. That was you, right? It's great. Because if you Google a question, you find some jerk on Stack Overflow telling you you're an idiot, right? But you're not. You're a 12-year-old. And we're trying to teach you how to close read in every class. This is a class. We need to teach you how to close read. So let's talk about some context clues. I don't know what concatenate means, but I know what cannot means. And I've been talking about strings, and I've been talking about integers. So I can't do something with a string and an integer. And what is the operation that I'm trying to do in my code? I know what that is. What is it? What? Add, addition, right? So what does concatenate probably mean? Add. It's the only thing that's not up there. They can do that. So then, oh, this is another one that's good. The little hand symbol, you'll see that in some of my slides. That means write it down. So students don't have to take notes unless there's that symbol. If there's that symbol, it's free reign for me to check your notebook at any time. If you don't have something that I had that symbol with, you lose points. This works super well. I have not had a kid ask me, do I have to write that down in about 2.5 years? It's really nice because you multiply that by 30 kids, it's a lot of time lost. So to join plus together. I like doing definitions that have the definition in them, even though that's a bad practice. So I'm joining together in this definition. I'm concatenating. It's a visual representation of what this thing does. They're going to see the word concatenate when they try to combine strings. So I'm going to write the definition as the addition of 2 strings. Does that make sense? Cool. All right. So now we're going to have some other bugs. So any problems we can predict here. There's not necessarily a problem in my code. Now we're thinking about user experience design, or whatever you want to call it. Your user could do something you didn't anticipate. So having students think empathetically is something that doesn't necessarily come up in a lot of CS classes, but it's hugely important, right? If you're designing a website, of course you know where the buttons are. If you're writing something, of course you know how to trigger it. You know what the function's called. You know what the variable's called, but your audience doesn't. Your audience shouldn't have to. So this is an example. My last name is SK. I had them try to think through what might happen, what might be some problems here. So I'm the user. What if I type, like they all do, my username with lowercase letters, right? When they type in their emails in school, they can type them with lower or capital, doesn't matter. Why does it not matter? That's kind of interesting, right? Because it does matter for a password, it doesn't matter for username. Well, we can start learning about dot notation now. But we introduce it with the problem first. So it's not, I'm your teacher, the guy in the plaid and the glasses, I'm going to talk about dot notation. It's, there's something weird going on in your computer that you've seen, why is that happening? And flipping that, rather than being like, here's the programming concept that someone decided was important, versus here's an actual thing you've seen in life, how does that happen? Is really powerful, especially for young learners across any of those 3 groups I talk about. So then they walk in, and this is progressing through the Python unit. I'm doing like 6 weeks of work in about 8 minutes. They have a pop quiz, except they're going to build it. So instead of using a Google form to make a quiz, they're going to practice using conditionals in Python to build a quiz. This is a really fun activity. It exists in a lot of programming courses. Students can write the quiz about whatever they want. So this is another way of getting every student involved. So I had students ask, could I write a quiz about Harry Potter? Can I write a quiz about sports? Can I write a quiz about this pop star? I don't care as long as your code works. Having that kind of flexibility I think is really important when we're talking about differentiation. I'm not just talking about in terms of students with special needs and students without special needs. It's the fact that my school has mandated CS, other schools have mandated CS. If you mandate a subject, some percentage of kids are going to hate it, some are going to love it, most of them are going to be like, I have to go to class now. So as much as possible, if you can make the grunt work something that they're interested in, and then have the code be an enabler of that, you have much happier, much more engaged students. So I really like this assignment. They get to practice writing conditionals. And then I'll do things like this with a small group. So why am I using dot lower? What might be some problems here? And then what am I highlighting? Indentation, white space, right? So trying to, again, use colors, use cues. OK, there's another check for you guys to see if you're paying attention. Cool. Remember, you can either be engaged or you can be taking notes. OK, so this is what a typical day looks like when they walk in. This is what I meant by they don't need a computer to do this, right? You can walk in and write a Python variable, write a variable in Python called score that has an integer value. This would actually probably confuse them now that they've been doing Arduino, which requires you to declare type, because Python doesn't, but that's fine. So this is the sort of thing they can do, and they can write down in a binder, no computer required. So I find these to be very helpful because I can just sort of walk around, whip around, and see if we're all kind of on the same page with our understanding of the syntax. This is the kind of checklist they'll see for a project. These mostly exist actually on my classroom website. So students have access, actually you all have access, to every single lesson that I've written. It's on my site. They can just go and find it. And the nice thing is, if they forgot what, I don't know, how to check for a non-numeric answer or whatever, they can go back 2 or 3 days, find that slide, pull it up. They don't need me. So again, I'm getting to the individual student, but I'm making them figure it out. So I'm addressing those groups, and then if they need an individual thing, I try to make all of these supports possible. The extension at the bottom, my school grades out of 4, so 4 is like 100%. They figure out how to implement score. That will eventually be a 3. So if the day that this slide was first shown, the day they got this checklist, if they figured out how to do score on their own, that's the totally bored group. I didn't show them how to do that. They would need to figure out how do I implement it. If they do it the way most of them figured out, the score was always off by 1 because they didn't initialize the variable correctly. So the kids that figured that out, that's awesome. Eventually, I want every kid to give a score in their quiz. So a couple days later, this will be what you need to get a 3 is to have a score. But I may have those first students that figured it out go teach that because they figured it out. And that's another really powerful way to use those different groupings. This is pulled from a student, so I guess I didn't anonymize it. But what's the problem with this? This is fun. Kids do this all the time. You don't have to know any code except for what the word lower means. It means lowercase. Yeah. They're never going to be right. They made their quiz impossible to get right because mint and green is title cased, meaning the correct answer has a capital letter in it, but they're checking it against an answer that's always going to be lowercase. They didn't mean to do that. They weren't being evil. It was just they were writing the way they're taught to write in English. But the way we did some error avoidance was we made everything lowercase in our quizzes. Yeah. They do. So their code, this is what I meant about the difference between a linter and a what I call it, test suite. Is that what you call it? I don't know what you call it. Test cases, thanks. I'm not a programmer. This code is totally right. This code will work. It will be fine. You can take Jesse's quiz. You will always get a 0 on this question. So he knows what dot lower means. He's just not thinking about what's actually happening at the end. So the code works, the thought isn't there, right? What? No, they do. I think the difference is they're not thinking one step beyond. I mean, I can't bring the kid in and talk to you about it, but.
So there's a difference there. I think what he's saying is like, there's understanding like what dot lower means, like it's going to do it, but like the context of like, okay, why do we do it? And
right.
What does that mean? And what is that? How is, there's a difference between saying I understand what dot lower means and I understand the context of allowing users to type arbitrarily case things.
Right.
And how many, like, there's like.
Or what the word arbitrary means.
Yeah, sorry.
Yeah.
As well. But like you could argue a kid understands dot lower. Here's an all
I will
capital
argue
thing,
that they
give
don't
me dot
totally
lower.
understand what it means.
But there's the why and the what.
So if I'd given a quiz that I wrote instead of a quiz that he wrote, and I asked them, what does dot lower do? What does dot upper do? What kind of data can you use dot notation on versus not? They would probably have said lowercase, uppercase, strings. Because you can
But there's, like the fully understanding is not.
Right, so that's why this happens at the beginning of the lesson. Right, this is a do now. They walk in. This is one of the few times I'll ask them to copy code. And what does it say they're supposed to do?
Kind of off.
Right, then they do it. That's the point. Kids don't understand things. I mean, some of them are. Again, some of them aren't. Not every kid gets 100% in my class. Right? I wouldn't get 100% probably in my class. I'd make a dumb mistake like this. And again, it's not a dumb mistake. It's an iterative process. You type things, they're wrong, you fix them.
Not the dumbest mistake at all. This is the kind of mistake that a professional programmer will make.
Awesome. So I can hire, Jesse can come work for you.
Yeah, I mean, it's not about understanding lower. It's about thinking critically about like,
Right.
what's the reason why you're using this function, and what's like the kinds of
Right.
like, what's the purpose of that,
Right,
comparison.
if the purpose is to make everything lowercase, why would you compare it to something that has an
The
uppercase
purpose isn't to
name?
make everything lowercase. The purpose is to allow people to
clean
type
the input.
case-insensitive stuff and
But
still
then
be able
what-
to check
but
the
So
answer.
this kid understands that people might put capital letters in weird places, and that putting dot lower fixes that.
Right.
That's what he understands. And then he's not
Then he
thinking about it when he connects it to
He
the
doesn't
degree.
understand the output of doing the lower.
Yeah, but it's like a process, right? I mean, this, first of all, it's middle school. And
So two things I would say. One is the it's not quite a logical fallacy, but it's kind of a jerk thing to say that any of us who teach CSNYC can say is, okay, so compare him to an 8th grader who doesn't know Python, like he's doing pretty well. The more important thing is kids get things wrong all the time, and it's way better if we can identify the thought process. So if I have students who are using dot lower, they are thinking about a user. They're thinking about, I want to make my code actually have the objective it was supposed to have, which is see if they can get the answer right, not if they can get the spelling right. So I know some way of implementing that. I remember something Mr. SK said about case sensitivity, so I'm going to try one of those dot notations. And I messed up one case. I have 10 of these questions. I pulled one out. I have 100 students. More than one of them made this bug. After this do now, less of them, fewer of them, made that bug. That's what a teacher does. When you look at a math class and a student makes a mistake, you don't say that kid doesn't understand algebra, they don't understand functions, they don't understand graphing. You say they made a mistake, let's talk about it. So I think if you're going to teach this stuff and not expect perfectionists on day one, you need to be looking for these, pulling them out. Maybe I should have anonymized it, but he didn't care. That's how teaching this works. It's good teaching, it's what we think
Right,
is
but
good
you also
teaching.
need to understand, so what is it the kid needs to fully understand, right? There are two things that the kid is understanding here. One is that the user can type lowercase, uppercase, whatever, and you have to think for that. The other thing that the kid needs to understand is what comes out of doing the lower.
Sure. What's your point?
Just there's the whole understanding process.
Yes.
that
What I'm
needs to
hearing
happen.
being said is that there's levels of understanding. There's
Sure.
and there's, I guess, the full breadth of understanding of lower is getting to that last part, which is
Yeah,
what you're
the other
working
thing
for.
that I try to keep in mind for myself when I get annoyed by things like this or other mistakes I see is we're basically asking students to watch 7 episodes of 7 different TV shows every single day. My class is 40 minutes long. They come from a different class that's 40 minutes long. That's a very strange way to absorb information and use information. So in terms of retention of things, that's part of why I try the note-taking strategies that I try, but they're going to make mistakes. They're going to make them repeatedly. They're going to make mistakes that I think that I taught. One of the fallacies of teaching is if I taught it, they learned it, right? So I can show this slide 1,000 times, and there'll be some kid that does the wrong test case. So there'll be some kid that does 3 equal signs because he thinks he's or she's in a different language. There'll be kids that forget all kinds of stuff, or they'll mess up their white space. And it's hard to pinpoint exactly why that's happening, but that's why I do these do nows. So I think we're kind of saying the same thing, which is you need to identify what the actual misunderstanding is. I feel like this code is pretty clear there's one bug. You can make some arguments that Jesse's a bad variable name because it's actually his name, but that's a separate issue. All right, so then we keep moving on. This is actually going to be like the session that's next. So talking about functions. So they've seen functions in previous years. They're in 8th grade now. They've seen functions in JavaScript. They've seen functions in Scratch. They've seen functions in math. Right? So 2 different questions. What is a function? I will accept a wide gamut of answers. If there's any math teachers in the room, you know that definition kind of shifts from early year math to later, but you can accept input outputs. You can accept series of steps. But you sort of see that there's an understanding that this is a concept larger than just the place we're seeing it now. One other change to my slides. Top right. Yeah, so there's a reason for that. I started seeding this in the Python unit. They weren't actually going to learn binary until the unit they're in now, which is Arduino. But they start to wonder, why the hell is he writing the date like that? And this was just kind of a test for me to see if they could figure it out. But then once we got to binary, you get one of those great oh moments because once they saw how the 1s and 0s work, they realized what my date was. That was kind of fun. So one of the nice things about the way the software engineering pilot works is they see concepts repeatedly. So the curriculum spirals. I think you guys probably do this too. We start with Scratch and then move on. So there's a progression that they see in Scratch. We start with some kind of script, a whole bunch of steps. Then we figure out we can make the computer repeat it for us because computers are fast, people are slow. And then we can actually give that thing a name. That's a function. OK, it looks like this in Scratch. It's not going to look nice in JavaScript, but it's actually the exact same thing. And it's not going to look like it in Python, but there's a reason we do this. So I actually use the same slide every time we learn about functions because I'm trying to hit that understanding, right? I care more about, do they understand what a function is, why a programmer doesn't just, because the first thing kids ask is, it's a lot more work to actually define a function the first time than it is to just do the script that I knew how to do. Why do I have to bottle it up and give it a name and check all this other stuff and remember the different syntax for JavaScript? And that's annoying. And why does it call the variable? Because someone said that in JavaScript, it made sense to call a function a variable. I don't know, I didn't write it. So here's why. And this is, again, this is not really about Python. This is not really about any particular language. This is a principle. This is an understanding. So this is the kind of thing I want them to feel comfortable saying, even if their Python functions have bugs, even if their JavaScript functions didn't work. When they're in 8th grade, I want them to know that. And that's a conversation we can have. That's a conversation I can have with any of those groups, even if I have some kids that can write functions that activate with event handlers in JavaScript. I didn't teach them, and I have kids that are like, I crashed Google Chrome, oops. So this slide has really nothing to do with any particular syntactical features. This is about, do you understand, down the road, this is why people are doing the things they're doing. And again, as much as possible, so they've done JavaScript already, as much as possible, I'm going to try to bring those understandings to the same place. So I start with a madlibs project in JavaScript. The first functions project they do in Python is they're going to build a madlibs in Python. So they actually go back, see the code in JavaScript, and then try to actually translanguage, help me, translate, translanguage. Translate, right? OK. So they're going to try to translate their code into another language. So they see this, and I can go pretty quickly through the definition of a function in Python. Really, all I need to talk about is white space and colons, because everything else, they kind of understand what's going on. They were confused why there were no brackets. I said white space is like brackets. It's going to give you structure to code. If you forget them, the computer will yell at you. OK. This isn't foolproof. There's obviously things they can do wrong. So again, I'm trying to use color and, why is it not working? There we go. Color and just little things in Google to help me highlight what I'm actually talking about. So there's a bunch of stuff on the screen. We know that functions have to be defined. We can probably figure out what def means. We know that functions from JavaScript take a parameter or an argument, depending on which book you read, or if they mean different things. I don't know what they mean. But there are features that are different. So we're going to highlight those, and I'm literally highlighting them. And again, this is the sort of thing that I'm asking students to write down. So you see the hand. They're writing down functions have to be defined and called. They're writing down the things they need to watch out for. This is much more useful than just having a bunch of function definitions in front of them and trying to write their own, I think. again, a checklist. The exercise 10 in functions refers to probably Codecademy, probably not Trinket at this point. But it's an arbitrary point. Why do they pick 10? Because it's an easy number. What it let me do was very quickly get them into those groups. So some students are going to get to 10 very fast. Some aren't. Some are going to get to 5. That's fine. If that's actually assessing for their understanding of Python syntax, that's great. I honestly don't care if it is, though, because what it let me do was very quickly get to smaller groups of students. So maybe the student who's struggling to get to exercise 10 actually understands Python syntax and she just isn't typing quickly. Okay. And if I talk to her in that middle group and it's a little bit below where she needs to be, she got an interaction with the teacher. She got to talk about Python, which is an experience that she wouldn't get if I just had everybody on the track at the same time, or if I just sort of decided, I think you're ahead, I think you're behind. I use these external platforms as a way of very quickly dividing the students, and when those groupings are wrong, I let students correct me. I feel very comfortable with that. They're very honest about that. So yeah.
How many students are on average in your class?
30.
30?
Yeah.
Okay.
My smallest class is 26.
Okay.
Yeah, and that's a high school. That's a pre-AP class. So it will be an AP class next year. Go CSP. So then we move on. They are now in an IDE. So I kind of skipped ahead, but they are now completely out of those coding platforms. So now the groupings that I'm doing are based entirely on rubrics that I'm writing. So if they get a certain number of things correct, or they have a certain particular error that we're looking for, or they achieve the objective of the code, they'll be in a different group. I like these sort of what prints do nows. These are a way of seeing, can you read through the code? Can you actually understand what's happening? Often the next thing will be kind of why, or there'll be a little trick. This is an example of what a small group would do. So I put up 2 different functions. These are almost exactly from a Codecademy exercise, except for one really jerky change. There's a function that in Codecademy checks for divisibility by 3. That's on line 6. And I made one small change to see if students actually understood what the function was doing. This is kind of going back to that I am right, I am wrong idea. So the function's still called by 3. It looks exactly like the thing they saw checking for divisibility by 3, but it's actually checking for divisibility by 2, because I'm a jerk. But they like catching those things, and they can catch those things. And this is letting me assess for, do you understand what the code is actually doing, or can you just read the English words in the code that you understand? And those are 2 very different things. Then they're going to recreate the Mad Libs. So this is what they did. This is actually from a student. This is JavaScript code to write a Mad Libs, and they're going to translate it into Python. So that's this. One of the things that I think is really important for differentiation, but also just for teaching young learners code, is the vocabulary that we attach to coding is preposterous. There are multiple words for the same thing. There are very pedantic debates, and there's also a lot of preconceptions about what prior knowledge is required. And one of the things that's blown me away continuously is I'll meet people who are like, well, you got to know algebra before you can do Python, or you got to know statistics before you can do this. You got to have calculus before you can do whatever. And one of the things that I think is really nice about what SEP has done and what a lot of the programs in this room are doing is we've kind of said there is an amount that is age appropriate for a young learner. In the same way that we ask kids to read novels and write essays, we can ask students to approximate a professional product at a way that's appropriate for their level. That, like, I want kids reading Shakespeare before I would expect them to write a 5-act play in iambic pentameter. I wouldn't expect most anyone to write a 5-act play in iambic pentameter, but I want them to read it, and I want them to appreciate it, and I more importantly want them to understand the craft that went into it. And if you understand the craft that went into something, you can see it as a model of possibility for yourself, right? So, like, I can read a Shakespeare play, and if I'm totally lost, I'm never going to think it's something I can do or something I can enjoy. And if my teacher has broken that down in a way that isn't boring, but makes me gain respect for the craft that went into it, I say, you know what, I can't do that, but I can do this part right here. I can't build Facebook, but I understand how the login page works. And I can't build the entire gradebook, but I can build a feature the gradebook doesn't have. And that's a really empowering moment for all of these students. And the thing that these groups let me do is they let me get every student to that base level of I can write the essay. And we're still trying to figure out what the novel is that students should be reading. And that's really hard because you can show students a code base for something. It can be very intimidating and turn them off. And so the last thing that I want to talk about is what I've decided to do as a commitment for myself is that there's a thing called the teachers college reading and writing project, and they do a lot of stuff for English, but one of the things they do that's a really should be intuitive insight that isn't for everybody is they have this idea of the teacher model, that anything you're going to ask a student to write, any essay, any research paper you ask a student to write, you should have written yourself. And you should actually try to write as much as possible of that paper in front of students, which is a whole other conversation. But I have committed that if I can't find the right essay or the right novel for my students to read, I'm going to try to write that. I'm not writing novels, I'm writing projects that they can either approximate or they can complete. And that has completely changed my practice, and it's very different than the way that these CS programs in later life work, where that there's not a gateway for my students yet. Everyone has to do it. And so because everyone has to do it, I have to have the expectation that I can take every single student through that I can sit next to that last group that's really struggling, and we can work through that code in a realistic and rigorous way together. So I hope that I've shown you some useful examples of what that looks like. And then sort of big strategies that I have in my classroom, at least 3 groups. This idea behind note-taking and accountability for the note-taking, making it meaningful, making it purposeful. I use a lot of GIFs. And the GIFs for me, that was a way to remind myself, my approach to differentiation is whatever works. I will throw anything at the wall. So there's this idea called understanding by design in teaching. Have you heard of this idea, understanding by design? This is a very popular buzzword in education. I find a lot of times the things that teachers show are not well designed from a, like, if you're nerdy about graphic design standpoint. They are not pleasing, they are not engaging, they are not, and that's often okay, but there are things that design can teach us, and that's the reason that I do all the stuff with colors and fonts that I showed you up here. Obviously there's a typo on this page. There's the word design. So understanding by is written in a pretty font called Oleo script. Students love pretty fonts, teachers love sometimes pretty fonts. The one on the bottom is something called Andika. This is just a small example of what I'm talking about for design. This font's really ugly, but it has no symmetrical letters. So if you have students, and you do, who have reading disabilities from dyslexia to things that are less severe, they transpose letters. And so D's and B's, things like that, are hard to read. And this font has none of those. So I put everything for my IEP and L students in this font. And I have seen a student who couldn't read, I just like changed the font on his thing he was reading to this, and he could read. And it's not like I taught him how to read, it's that this thing is designed for people who have trouble reading. And little things like this, things like using color, things like making amusing GIFs that understate, reinforce your point, I do all of them, and some of them work and some of them don't. But my approach to teaching CS is not CS is really engaging inherently, or CS will get you a job. It's that this is hard and complicated, but you can build something, and you can create something new that's like the things that you love, and also like things that you've never seen before. And my job is to figure out what works for you. It's not to say you have to learn functions. It's to say you're not understanding functions. How can I build something that will help you understand functions? And that's the challenge, and that's why I like my job. So that was a lot. I can put up that. There you go. I think I'm even on time. Good. Questions? I have stuff I want you to do, but I'll take questions first. I forgot your name. Eric.
So with all the lessons that you put out
Yeah.
for the year or for the
They're all here, by the way, if you want all of my lessons for whatever reason.
Cool. Is the expectation that every student goes through every one of those lessons and they don't get moved forward until they've shown you that they've understood everything like along the way?
Yeah, so
Is it self-paced on some level?
I tried to draw what I envisioned this looking like, and I couldn't make the spiraling look the way I wanted. But basically, I have high watermarks that I want, or gateways, or whatever you call it, that I want students to hit. So the Mad Libs project was an example. Every student had to complete that.
Okay.
Some students implemented multiple features that other students didn't. So some students had it pull in random words from a library of words, or some students had it actually use the random function, so people entered words and then it slotted them into the appropriate place. They did things that were more complicated, but everyone had to write a Mad Libs project. So some kids got a lesson on like how do I import random, for example, because that wasn't something I taught to everyone.
Sure.
So some students got that, and then they tried to implement it, but everyone ended up with a Mad Libs.
Okay. So there's certain things that you expect them to definitely do, but at the same time, like, if there's kids who are, or students that are staying towards group number 1, we'll call them,
Yeah.
they're like, they
Totally lost.
totally lost, but
Yeah.
like, they're just always kind of, I don't know, wavering in that place. Like,
Yeah.
they move at their own pace, or is
Yeah,
that the way
and
you
one
try
of
to
the
structure things?
Yeah, and so in terms of the capital U, capital D understanding by design, I start with some sort of performance task that's like what competency they expect to demonstrate at the end of the unit. I have to get everyone there by the end of it. But that project can look very different depending on the student. One of the things, the reason I didn't call it high, medium, low, and the reason I try to make it move is that students really do move from group to group. And I certainly have kids by the end of the unit that are still not great at Python without someone sitting next to them, but they can, and then they write about it too. So the last thing I was going to show you guys is somewhere in here. Here you go. I just put in two. These you can read at your own time, but just questions I like to ask my students. How would you explain Python to someone who never studied it? How would you explain Python to someone who knew some code but not Python? And then what could you make of Python you couldn't make before? I ask these kinds of questions at the end of most units. And I pulled one from a kid that was pretty consistently in the totally bored and one from a kid that was in totally lost, and I don't think you can tell who's who. I know who's who, but I don't think you can tell. Because by the end of the unit, they can explain it pretty well. And whether they can go and do it perfectly, honestly, if they can write Python code 6 months after you finish Python, when it's July of between 8th and 9th grade, that'd be great, but that's an unrealistic expectation for 100% of my students. It'd be a beautiful thing, but it's not going to be true for every single student. So this actually counts as much as the coding, this writing that happens at the end. Can you explain your process? Can you explain your thinking? And this is a place that I can get all of them to.
Okay.
Does that help answer your question?
Yeah. I think what I'm trying to get at, or what I'm trying to wrap my head around is, like, is there a room for an expectation that, every student doesn't have to get through everything, and that you just kind of respect at whatever pace they're moving at for that? But it sounds like, yeah, on some level you do.
Yeah, and part of why I was thinking about the 15 a week rather than like 60 to 75 in a unit experiences, I guess, is that the right math? I don't know. But is that for my own brain not exploding, I kind of think at the week level of what you're going to be able to finish by a Friday or a Monday, right? Like, there's something I want you to have produced at the end of every class and the end of every sort of major step that may look different than your partners, but I don't want you still struggling with syntax while we're all writing functions.
So at the end of a week, they will all move on together.
To some
at
new
point.
experience,
Okay,
yeah.
I
And then there's there's those 3 or 4 experiences that are happening.
I see. Okay,
Yeah.
cool.
Hence the juggling with one hand. Yeah, no.
Yeah.
Okay.
Yeah, so I have a question about, you teach a lot of languages. So I'm looking at your 8th grade class, right? You do web design, which is JavaScript, you do Python, which is language, and you have Arduino, which is like C-like language. That's a lot of different languages that are pretty different.
Yes.
Do you find that I personally see a lot of value. Obviously, the students are going to see like similar things. They're going to see control structures and be like, oh wow, like it isn't, not every control structure is the same, but the fundamentals of control structures are the same. But there's also, like in my experience, a lot of confusion between like, I remember there were brackets in there and I knew language. And they end up like mucking up their sort of like process. What do you see as like the right balance there? Like, for me, that seems like a lot of language. Like if someone was like, hey, I have this curriculum for 8th graders, there's gonna be 3 languages in it, I'd be like, whoa, you're crazy.
Right, we did 3 at the same time. I mean, I know that programmers will tell me HTML and CSS aren't programming languages, and that's fine, but there are languages for kids. And JavaScript is, right?
So that's part of your web, right?
Yeah. It was not, I can't claim any credit for the philosophy, but the philosophy that SEP has, for better or worse, embraced, and I think for better, is that we go for breadth over depth in the younger years. That we try to do really engaging projects that hit on a lot of languages, partially to show students what's out there. And one of the things that is a benefit to that confusion is that my first year when I relied more heavily on things like Codecademy, also because I was learning, students would conflate the learning platform or even like the place where they were doing the work with the language. And so one of the things that's impossible to avoid if you're going HTML, CSS, JavaScript, whatever, Python, Arduino, processing, blah, you can't think that any one of these is code on its own, that they are all part of this larger universe and that you're going to use bits of each project. And that, to me, is a really valuable insight. And that it's really easy. Like, the thing that I'm most scared of when I see these learn to code initiatives for kids is that they dump them in one product. And because I've done that, I made that mistake where I taught JavaScript to my 6th graders 2 years ago, the same kids I have now, and they thought until this year that Codecademy was JavaScript. They did not have there was no difference. And there was no reason for them to have thought there was a difference because the only place they'd ever seen JavaScript as a language on its own was in this one website, so they thought they were the same thing. And by shuffling through so many things, yeah, there are gonna be kids who type brackets the first week of Python, and we're about to go into processing or P5.js, so that's gonna be going all the way back to the beginning of the year, right? But kids are surprisingly resilient, and they'll make the mistake once or twice, and then they'll figure it out. The same way that like it broke my brain the first couple of weeks of high school when like I did MLA in one class and Chicago in another, but then like I figured out how to cite my papers for that class. Why they had, I don't know. But I think one of the advantages of CS going from 0% to whatever percent we're able to teach is that we're connecting so many neurons. And like we don't know what that's gonna ignite in a kid's head, but like better to have them exposed to, and again, 6th to 8th, I think this changes for high school. 6th to 8th, the more things you can expose them to, the more connections they can make, the better. One of the things that's weird about the way we do most of our 6th, 8th, and then 9, 12 education is pretty much everything you learn in middle school, you revisit in high school. There's no, I'm a middle school teacher most of the day, but there's really no stakes to forgetting a lot of what you learned in middle school. Because you see, like, I mean, literally like our 8th grade science curriculum and our 9th grade science curriculum, and I teach in a 6 to 12 school, so they're going from one to the other, are very similar. What we did in CS is we spiral it. So they'll see Python in 8th grade. They'll see a little bit of it next year if we change this curriculum. Then they won't see it again until 11th grade. That's okay. By high school, it's for stakes. By high school, it's I need you to write Python that I'm going to send to the College Board. I need you to write Snap code that I'm going to send to the College Board. You're going to go, my 9th graders went out and interviewed. They worked as interns in tech companies. They needed to know that HTML and CSS and JavaScript were 3 different things and which one did which and which looked like which and syntactical features that they wouldn't screw up because they were writing code for companies that were paying them. That's a very different conversation than an 8th grader who's also like in social studies, in science, in math, and like this is one of the things they do. The same way that like we jump in history all over the place. That's not a great answer, but I feel like I'm okay with it.
Well, what I'm interested in is like,
Yeah.
like the concern that I've gotten from students. My students are not young,
Right.
But the concerns that I've gotten from students is they're like, oh, you're trying to teach me some new concept, but I'm really still struggling with the new language that you're teaching me, and so I can't learn
Yes.
like hash tables or you know binary trees because like I don't know Swift yet or something.
Right.
That's like the specific concern I had yesterday, for example. And like I don't know if that's because I'm doing it wrong or because that student's just a whiner or if there's like, because like I was looking at your curriculum and it looks like the Python is different material than the JavaScript.
Yes.
You're not teaching them tip calculator in JavaScript, right? That's a Python.
Yeah, it's a Python project.
And so like, do you get that complaint ever?
I think that's a valid thing. I'd love to have people pick at what we're doing. One of the, and like part of it's that this is the first time all of this has been taught. So eighth grade software engineering has existed for however many school days there's been this year. So the next time I teach it, the next time we teach it as a cohort of teachers, it'll probably look different. And I think one of the things that I've been adamant about doing with my juniors who did Snap for a semester, which is a block-based programming language, and now they're doing Python, is for the first 3 months of Python, all they're doing is translating. So they're going to their old projects in Snap and they're redoing them in Python.
It's not very fun though.
It's not super fun, but it's a really good way of learning the syntax of a new language. So that's the trade-off. And like, I'm okay with 8th grade being more fun and less, can you write production code? By 11th grade, they need to be writing stuff that I can send to an external validator. By the time they're getting jobs, they need to write stuff that can work for that job. But I think making the connections across languages in middle grades is more important than knowing one language really well, because they're not going to know one language really well. They're just not.
I mean, there's also a difference between I'm learning a language versus I'm learning a programming concept.
Yes.
Right?
Yeah.
So language, I'm learning JavaScript, I'm learning the syntax, I'm learning the grammar versus I'm learning the loop is something that repeats things.
Yeah. Other questions? Yeah, what's your name?
Sarah.
Hi.
So one of the things I'm interested in with you have your 3 groups is letting students self-decide what group they're in versus you deciding what group they're in and how that dynamic works.
So last year, we built a sound logger using an Arduino and an SD card, and we put them in every 6th grade classroom. Right about the same time, I decided to start trying out this grouping thing. And as you might expect, my classroom is pretty loud. So in terms of how it works, it's a process. At the beginning, I'm pretty adamant that they go where I have instructed them for a variety of reasons. One, that's the instructional expectation at my school, that I have accounted for every single student with data for why they're in the group they're in. That gets fun when you're writing the data and the curriculum. Well, you're writing the tool to get the data and the curriculum, and you're the only one who's ever taught it. So you're kind of like, well, I can get the groups I want. But that's the expectation at my school. So I have justification and a written place for every student to be. That being said, like I said at the beginning, if a student's like, SK, I do not understand what you're talking about. I'm like, okay, come back for this. I'm fluid with that. And sometimes it's not them saying it in that tone of voice, it's them screaming at me from the back of the room, I don't know what's happening, like, right? And it's like, well, just come up. Like, you are supposed to be writing functions. I'm explaining functions. If you can't do it on your own, just walk up here. Like, you're not actually a grown up, but like, you can walk, you can do it. It's more important, I think, I can't tell you how to build a culture in your room or in a classroom. So I can show you lessons, but these lessons exist in a culture. And these are students that I've had, some of them for 2 or 3 years. So part of that is about trust. And they know that, like, they know how the room operates. And I think that that's, if we had more time, I was gonna have everybody who's a teacher draw their classroom to see what it looks like. But I think part of how any of this works, and at a meta level, like how I'm able to test new things in my room, is that there's a level of trust between my students and myself, and that, like, they have seen me mess up. And my favorite thing in the world that has happened is I was doing one of these lessons and I was like typing something, and the girl was like, SK, you're writing JavaScript. And I was like, what? She's like, you're writing JavaScript. It was in the middle of the Python unit. And I was just like, that's totally wrong. Like, I am writing the wrong language on the board, because I had been teaching JavaScript. There's no excuse for it. Like, it happened. And like, they caught me and they called me out on that. And I think that that's awesome. And I was like, you're right. You get a school buck, which is our school currency. Good job. Now let me fix that. And having that atmosphere in your room is more important than any particular strategy I could show you, because that's not a lack of rigor. That's not a lack of accountability. Like, I have rubrics, they're Common Core aligned. These kids have quizzes. They're writing, like, they're doing the things they're supposed to do. It's not loosey-goosey. It's not a makerspace. It's a classroom. You can have that debate later. But there's a fluidity to it where they're like, I am lost or I am bored. I will come back to you. And like, there are times when I call kids based on, like, for example, the Code Academy lesson. I'm like, if you're on 19, come up for this. And the kid's like, I don't want it. I want to do it on my own. And I go back and forth, but like, I know my students. And if it's somebody who I can trust, and she's like, I want to try it on my own, I'm like, great. That's a much more valuable use of your time than hearing me talk through it. So it's a fluid process. And I think if you were a starting CS teacher, I would want to talk, before I talk about any of this, I would want to talk about how are you arranging the computers in your room? How does the flow of your class work? Don't ever let kids touch a computer for the first week of the school year. Don't have the computer be the goal, have the computer be the tool, have the project, have the process, have the thing they're building be the goal. There are great days in a CS classroom and the only thing you touch is a pencil and a piece of paper. There are lessons they remember way more where they never touch the computer. So those are things that I can't really show you in slides, but that's what lets you do all of this.
So what are your thoughts on like having these 3 groups of lost, totally get it, and bored?
Yeah.
And nice. The kids moving through the 3 groups, and they're like self-image.
Their self-image, like, are they
Especially
embarrassed about
like
being
for girls,
totally
right?
lost? Oh, my girls, can I curse them? No, my girls kick butt.
I know the girls kick butt, but
so part of that,
there is something about like, now I'm gonna go to the totally lost group, right? What does that say about me?
yeah, no, only because it's not set in stone. It's fluid within a lesson, and it's fluid within a week, it's fluid within a unit. And students, I have not had any students that I've seen, again, it's from my vantage point, but I've not had any students shut down or stop. If anything, like, being lost for a day is like a motivator to get back. Students want to be, they know where these things are moving, they know it's moving that way, they want to move that way. The self-image thing, I used to teach 6th grade software engineering, and the boys would come in on September 8th and be like, yo, computer teacher, I know everything. And I'd be like, you don't know anything, shut up and sit down. But no one knows anything. And that's an important, like, I'm very frank with my students about that. I think it's very important to be, like, that's a whole other presentation, but setting up a culture in your classroom that is a feminist culture is essential to being a good CS teacher. That's not what I'm presenting about, but I believe that very strongly. That means, like, shutting down that behavior of, like, I'm smart at CS before you've demonstrated it. It means having that be something that's tied to, when you are smart in CS, having that tied to graciousness, having that tied to helping, having it be the expectation that if you are exceeding, you are also going back and mentoring or you're documenting your work so someone else can read it. Having very explicit conversations about the environment that we have in here is unusual. That like having more than half the class be girls is unusual. And having a class where, you know, so for example, if you teach computer science, the posters you get for free are all like Steve Jobs, Bill Gates, Mark Zuckerberg. I don't put those up for a reason. And I tell my kids why I don't put them up. And that's, again, that's the culture thing. Like, I can show you, but like the posters in my room are all women. There's for a reason. When I take trips to Google, it's only girls. That's for a reason. And I tell my students why they're not going. Because the boys are like, when do we get to go to Google? And I say, I'll do it right now. Women, in the room, if you have ever been told you couldn't do something because you're a girl, raise your hand. Anyone in the room ever been told they can't do something because they're a girl? All the girls raise their hand. And I tell the boys, for today, you can't do something because you're a boy. See how it feels? That's an important conversation that, again, is not about functions or Python or any of this. But that sets up a room in which like the work and the thinking and the helping and the conversation is way more important than the particular syntactical features that they're talking about. And it's more important, no offense, than getting a job in computer science. I don't care if none of them work at Facebook. I'd be totally fine with that. But if they want to walk into a CS class in college, they're going to be going to college in the next 5-ish years. They're still going to walk into a classroom that's 14% girls, 12% girls. And none of them are going to look like my girls, because all of my girls are girls of color. And I can't change that demographic of the classrooms they're walking into, but I can try to prepare them. Because there's going to be days, especially if they go to a college CS class, where they're in that totally lost group for 6 months. But now they have an idea that there's always this distribution. And when I get it, someone else in the room is lost. And I think that's a more powerful insight than being like, well, today I'm lost, I'm going to give up. Like, that's not an option because it's an everyday class and they're going to be in it tomorrow. Sorry, I got kind of carried away. Any other questions before Sean's going to stop me?
I'm going to stop you.
He's going to stop me.
Yeah. I mean, you guys can so there's
If you
a
want
15-minute
to send me somewhere,
I'm sorry.
I was going to put up that. All right.
We can also, you know, in the slideshow, I'll put it in the notes document so that, like, are you cool with that? That I just dump it on my contact info?